Newton's second law. So it allows us to find mass, acceleration, or net force given the other two. So we know we have acceleration is equal to the net force divided by the mass. So in this situation, Mr. Teeters is sitting in his rolling chair and is suddenly pulled across the room by Eric with a net force of 115 newtons. Right, so I'm just sitting here, right, minding my own business. A little chair here, the wheels. There's Mr. Teeters, just sitting here minding my own business, and all of a sudden, here's Eric. Comes up behind me and pulls me across the floor this way with an unbalanced force of 115 newtons. And as he does that, he causes me to accelerate at 1.4 meters per second squared. The question is then, based on information, what's the mass of Mr. Teeters, of me, in my chair altogether? So we just look at Newton's second law here, and we'll plug in for the acceleration 1.4 meters per second squared. That equals the force that Eric applied to me, 115 newtons, and solve for the mass. So we'll just do a basic cross multiplying. 1.4 meters per second squared times the mass equals 115 newtons times 1 on the bottom there. And so I still want to get the mass by itself, so I'm not done just yet. So I'm going to divide this side by the 1.4 meters per second squared, so that'll cancel out. If I do it to this side, I have to do it to this side over here. So 1.4 meters per second squared. So that means I have a mass equal to 115 divided by 1.4. This works out to be about 82 newtons per meter per second squared. That doesn't look at all like a mass. A mass should be something like grams, kilograms, something like that. But remember, the Newton is a kilogram times meters per second squared. Again, the force required to accelerate a 1 kilogram mass at a rate of 1 meter per second squared. So if I plug that back in the place of the Newton there, kilograms times meters per second squared, all that divided by the meters per second squared from right here. Those meters per second squareds cancel out, and that leaves me with kilograms. That makes sense. So 82 newtons per meter per second squared is actually just 82 kilograms. So that's the mass of Mr. Teeters and my rolling chair all together.